An activity 5 review and recap. So this is, we're using NetBeans 8.2, which is an old version, because it also comes bundled with an old version of the Java Development Kit, version 8.11, which works just fine with our PicLab from the College Board. Discussed in the first 4 activities. We are simply talking about how we can represent colors in 8-bit format called a byte, and how this value of 255 is used to control levels of RGB that we can then bundle together into hex codes that handles our RGB value. So we're just going back and forth between these numbers because this is represents a fundamental understanding of how we show pictures. And so then we start using the Picture Explorer and accessing different files. That turned out to be a big pain because we had moved to Visual Studio Code for robotics, and that caused all sorts of problems. And even in Eclipse, we were using a latest version of the JDK, which doesn't play well with this project. So you may need to adjust your file chooser so that when you try to access a picture, that it knows where to locate that picture. We can experiment with that in class if you need any help. But what ultimately that we're going to do after the first 4 activities, where we understand, the last thing that I would mention is that we understand row major representation of information, where our collection of int arrays, we imagine them stacked one on top of each other to so each group in our container array represents a row. That's an important understanding because we could just as easily put this on its side and have each column, each collection of numbers or pixels or whatever represent a column instead of its row. But that's how we are going to be using this information, and that will be very important as we loop through everything and loop through all of these pixels and change their colors or what have you. So we're going to look at that as we go through a number of different and pretty fun exercises. So that's uncommented here, that's being run in my picture texture, tester, is called test 0 blue, and we see here the output is a picture that has no color blue in it. It gets called, we're creating a new picture or instantiating a new picture and passing it the string that the file chooser will use in order to summon up the file and then show the original in the Explorer. I have that commented out so I don't see so many. And then I zero out the blue. The 0 blue, you can see I'm calling it from the beach object. And the beach object is a type of picture. So the 0 blue is going to be defined in the picture.java class. And you can see that it was right here. And then so is the Explorer function that was given to us, as was this example method. But this is something that we're going to have to do a lot. And so the first thing that you see me doing here is getting a 2D array of this picture. So get the a 2D row major arrangement of the pixels. So that way I'll go through each row in my outer loop, and then as I go through each row, so I'll go through each row in my outer loop, and as I go through each row, I'll then go through each column, and that's what's happening here. So go through each pixel object, or I'd normally label this like column or pixel. Anyway, and this would just be simply row, and you'll see I do that a lot more here when I write my own. But then as I go through each one, I set that pixel object blue value to 0. And even though that this is a for each loop, I warned you in the past that for each loops like this that will really mess you up. If I run this, even though I'm adding one to each, that if I printed it out, the value didn't stick. Um, and that's because as n traverses the array I have here, it's actually copying the value. But that is okay, and that is just fine in an instance where the value that you're copying from this array is actually a reference. So sure, you can copy that, but what you're copying is an instantiated object where, because I'm just telling it to run. So if you pass me the remote control to you make a copy of the remote control, that's fine because it still controls, it still allows me to call methods in the object over in heap memory. So anyway, for each loops, because they're passing references, a throwaway variable clone of the original is okay if I am making that instance do something. Um, so I'll go through each pixel and zero at its blue, and that's the example that we're given. I'm going to click this line and do command slash or control slash on a PC and comment this out. And let's click this one and uncomment this line. And if I run this file now, you'll see my keep only blue. I have in a pattern here. And so we talked about this in class. And this is a trick that you're going to need in other activities. Um, what you see me doing here is that I note the first third by saying the outer row, the first column. So I just pulled the first column and I said, take your length and divide that by 3, and I just made a note of what that value is as an integer, and I did the same thing with the second third just by multiplying that by 2. So that way I get 2 of these thirds, and that would be the next value that you'd see. And then I just go through the same thing, but I use a normal for loop on the second loop as I'm going through all of the columns in this row. I'm going through a normal one so that way I can test this column value. If you're less than the first third, then that means that you're in this first group here. So if you're less than the first third as I'm going through the columns, then I only want to drop your green and red value by like 20%. So I'd multiply that by 0.8 and then convert it back to an int because it has to be a whole number. So I'm running, doing some math that would result in a double or a float value. And then I'm converting it or explicitly truncating the information. Just that's a fancy way of saying dropping the decimal, and then setting that green value. So I access that row at that column's green value, multiply it by 0.8, convert it to an int, and then set that back into its green value. And I do that for the red value as well. And then if you're not less than the first third in your column value, then it'll test to see if you're less than the second third in that column value. If that's the case, it does the same thing, but it does it at only 30% of your blue value. Of your green and red, keeping only blue. And then lastly, only the blue is left because I am bottoming out everything just by multiplying it by 0, which is a silly thing to do. I could just set green to 0 and set red to 0 as well. Multiplying it by 0 is needlessly complicated, but I was just copying and pasting these. Negate's a fun one, so if I uncomment this test out, so the negate test, did I write this out? Yes. It will load the picture it runs the negate function and then explores it. Negate, what it does, and we'll see this a lot in computer science, that if you want to find, if you have a range from, let's say, 0 to 255, if you want to find the opposite value, you take the maximum value and divide and subtract the minus. So, no, I mean, I usually remember that this is a little dark, but the easy way to remember this numerical trick is just to think about how we describe each other's age. So if say the average human lives to about 80, if I say I'm 20 years old, then the opposite of that would be 80 minus 20, and saying, okay, I have 60 years left to live. And so you just flip that. And so the opposite is max minus current, and that flips that range. And so if I run the negate like so, you should see what looks like a photo negative. And so it's just the opposite colors of everything. Through the guide, get the rest of these tests filled out in Activity 5. They're really fun. Let me know if you have any questions. And in class, we're going to start with some transposition. So we're going to start reflecting and copying pieces of our picture, which will be really fun too. But for right now, we are just tinkering with color filters.